Okay, hi everyone. My name is John Davidge. I'm a software developer at Rackspace, concentrating mostly on Neutron. And today I'm going to talk about a new feature that we've just added in the Newton cycle called Subnet Service Types. So what are we trying to solve with Subnet Service Types? So the example I'm going to talk about today is the case of a router and its external gateway. So in Neutron right now, each router that has an interface on the external network is going to consume at least one IP address from the subnet that you've got configured on that network. Now, chances are, because it's an external network, usually you're going to have one or sometimes more subnets configured on the network that have pools of publicly addressable IP addresses. Especially in IPv4, those are obviously valuable resources, so we want to do everything we can to reduce the number of public IPs that you need to use for your infrastructure. Also, in the case of a router that's living on a compute node, the floating IP address, the floating IP namespace is created, and you can also have consumption of public IP addresses for that purpose. So if we can cut out the number of public IP addresses you need for both of those cases, then we're helping you to conserve valuable resources. So the solution with subnet service types is that in many deployments, your Neutron routers don't necessarily themselves need to have a publicly addressable IP. The floating IPs that you create for your compute resources do, but the router itself probably only needs to be able to talk to local systems. So with service subnets, what you're now able to do is to create multiple subnets on your external network, each designed to have a specific purpose. So you can have a subnet containing publicly addressable IPs for your compute resources, and then you can have several other subnets, either for router gateways or for floating IP agent gateways and so on, that can consume private IPs and are not going to be using your valuable public IP resource. So the way that we've implemented this in Newton is that the subnet resource now has a new attribute, which is service types. And service types is a list of none or more port device owners. They have to correspond to a valid port device owner, because that's what the Neutron IP address management system uses to decide which subnet the port you're creating should have its IP assigned from. And I did have a nice working live demo, but unfortunately I can't do a live demo in a BrownBag session. So imagine, if you will, that I'm executing these commands live. And the workflow that we're demonstrating here is that, first of all, you have your OpenStack administrator who comes along and creates an external network. They're then creating a subnet, and you can see the important part, which I've highlighted in bold here, is this new service type attribute. You can repeat the service type attribute as many times as you like. In this case, we're giving it a single service type, which is network floating IP agent gateway. And that means that when a port is created on that external network, ports with that corresponding device owner will be assigned from that subnet as long as that subnet has IPs available. The next subnet we're creating has a service type network floating IP, and you can see that in that case we're giving it a subnet range which is intended to be publicly routable. The first one for the floating IP agent gateway wasn't, and then for the third subnet we're creating, which has no service type, that also is being given a subnet range which is private and not expected to be publicly routable. Now, the reason I'm creating a third subnet there with no service type is that if I were to try to create a port on that external network currently, and that external network only had two service subnets with those service types defined, if the port didn't have a corresponding service type, like say it was a router external gateway, you wouldn't be able to create it because the Neutron IP address management system wouldn't find a suitable subnet. So by creating a subnet without a service type, we preserve backwards compatibility in that way. So then we move on to what your user is going to do, what your project's going to do. They go ahead and they do a router create. Then they're adding their own private subnet. I've left out the CIDR in this case, but it would just be a private CIDR. Then they're adding a router gateway to your external network. Now, that's the part where the important stuff is going to happen, because that router gateway, when IPAM comes along and decides which subnet to allocate that router gateway from, it's going to go ahead and do it from this other subnet, the third one we created, because that's the only one that could possibly have a router gateway assigned from it, because it has no restriction on service type. Then if we were to create a server and create a floating IP for it, it will be assigned from the network floating IP server, service type subnet. And on the third slide here, we can see that if I had done the demo live and it had all worked and I could then show you what the ports were, you can see that in the case of the first port there, that's the one that was created automatically for the floating IP agent gateway. It came from the 10.1 subnet, which was the one that we defined first with the network floating IP agent gateway service type. And then the second one, which is the floating IP we created, that one comes from the 192.168 subnet, which is the one we defined with the network floating IP service type. So you can see that in that case, just purely on those two ports, we've reduced the number of public IPs that you would be consuming from 2 to 1. And in fact, in this case, you'd also have your router gateway port, which isn't shown there. But usually that would also be consuming a public IP, and in this case, it's only consuming a private one. So in this instance, we've reduced the number of public IPs that you have to consume in this case from 3 to 1, which hopefully is a pretty good improvement, especially in IPv4. Now, some notes for people who want to go ahead and play with this feature. The support for the feature did not merge into the Newton version of the OpenStack client, and as far as I'm aware, it hasn't been backported. So to use this, you'll need to go ahead and install the OpenStack client from source at master. And the workflow is fully documented in the networking guide, which you can find on docs.openstack.org. Future work that we will hopefully get to within the next couple of cycles. This feature isn't currently exposed in Horizon, so we need to pick up the ball there and expose that. The documentation as it exists in the networking guide right now only focuses on a single use case, so we'd like to update that with more examples of where it can be useful. And we already have our nice first bug to fix, which is that if you currently try to create a service subnet with DHCP enabled, say a private subnet for your compute resources, automatically creating the DHCP port will fail because it's trying to create a port with type DHCP and it doesn't allow DHCP. So that's something that was overlooked, but we're going to get to fixing that soon and backporting it. And unfortunately, I've been told I can't take any questions on the stage. So if you have any questions, please feel free to assault me afterwards. And that's it. Thank you very much.